In this video, we're going to sketch graphs of sinusoidal functions that have horizontal and or vertical shifts applied to them. Now, in addition to this, also mixed in could be any other type of transformation, like a scaling about the x or y axis or a flipping about the x or y axis. Now, in the previous section, we focused on sinusoids that didn't have any horizontal or vertical shifting, so just scaling or flipping. And now in this section, we're bringing everything together. And so now here we're sketching sinusoids that can be as complicated as possible, any kind of transformation mixed in. Now, transformations can get kind of confusing when you've got a shift about an axis, and then and mixed in with that is at the same time is like scaling and or flipping. It can be hard to look at the equation and interpret exactly what it means. And we talked about this in the previous video when we went through the textbook, but this is really about the details of transformations of graphs. And we go through this in full detail in the algebra playlist. And so I would recommend that you go watch those videos, even if you already think you know about transformations of graphs. It would be useful to watch those again. And I'll post a link in the description to like a summary video of, in particular, this video summarizes the confusing parts about when you've got shifts mixed in with scaling and flipping, how to interpret that. So I'll post a link to that video in the description. You should check that out first before going through this video here. Okay. So, all right, here we can see this is a simple transformation. It's just the graph cosine of x, but shifted to in the positive direction pi over 2. Now, the way we're gonna go about graphing this is, so in the previous section, since there was no horizontal shift, we figured out what the period was, and we started at x is equal to 0, and then sketched up to the period, sketched the curve, and then just copied that period sketch up and down the x-axis. What we're going to do for when we have a horizontal shift is we're going to imagine that 0 to the period interval gets shifted as well, and then sketch on that, sketch the period on that shifted interval. Now, it's important to note, though, that there's no such thing as like a period interval. The period is just a period. You know, if the period is 2 pi, then you could think about the period going from x is equal to 1 to 2 pi plus 1, right? There's no period interval, but we're going to think about like a sketching interval, though, for the sake of sketching the curve. And that sketching interval would initially be from 0 to the period, but like in this case, we're going to think about 0 to the period has been shifted, that interval has been shifted to the left by pi over 2. And then sketch that, and then copy and paste the curve from there. So, okay, let's see. So here there's been no scaling about the y-axis, so we'll go from 1 to -1. All right, now there's been no scaling about the x-axis either, so the period is still just 2 pi. So then we'll do -2 pi to 2 pi, okay? So let's see, 1, 2, 3, 4, 5. So this would be -3 pi over 2. 1, 2, 3, 4, 5. Minus pi over 2. 1, 2, 3, 4, 5. Okay. So the new start point is pi over 2. So we would think about, we're going to be sketching from pi over 2 to 2 pi plus pi over 2, but we can't see, that's off the graph. So instead what we're going to do is we're going to say that the pi over 2 is the end of the period, and we're going to start at -3 pi over 2. So we're going to sketch the period from here to here. And all we're sketching is cosine x. So, okay, at the start point of a cosine, you're at the positive amplitude. There's no flipping about the x-axis, so you're at the positive amplitude, so we're here. Okay? And at the end, you're back at the positive amplitude. At the midpoint, you're at the negative amplitude, and at the quarter points, you're going through the x-axis. Or no, that's here. Okay, so now let's sketch the curve. All right. Okay, there we go. There's a period. So now let's copy that. Okay. And there we go. Now, okay, but how has the parameters changed? So in the previous video, we would sketch the curve and then say, okay, what's the period, what's the frequency, angular frequency, etc. Well, as far as the horizontal shifting, the period, or none of that has changed, because a horizontal, any kind of shift, horizontal or vertical, doesn't change the shape of the graph. Period, frequency, angular frequency, amplitude, that's all related to the shape. So that hasn't changed. The only thing that's changed is there's been a phase shift applied. And you can see we've got the sine curve here, actually, because when you shift the cosine curve to the right pi over 2, you get the sine curve. So what's happened here is all we're thinking about is how far away from the standard zero position of the function have we shifted. So the standard position is the cosine curve would be here. So there's been a phase shift. That's the difference. There's been a phase shift applied, but as far as the period, frequency, all those shape defining characteristics, none of that has changed. Okay, so now here we've got a simple sine of x that's been shifted to the left pi over 4. So there's been no scaling about the y-axis. So we've got, let's see, 1 minus 1. And there's been no scaling about the x-axis. So the period is still going to be 2 pi. So we'll go from minus 2 pi to 2 pi. Let's see. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so our sketching interval from 0 to 2 pi, again, the period is 2 pi. We're shifting it pi over 4 to the right. So halfway between here and here is pi over 4, so that's here. Okay, and now the sine curve at the start point goes to the origin, so we're going to go to start here, and then at the end of the period, we come back to the origin. 1, 2, so 2.5. All right. At the midpoint, we're back at the origin with the sine curve. All right. At the quarter point, there's been no flipping about the x-axis. At the quarter point, we're at the positive amplitude. So, all right. And at the 3/4 point, we're at the negative amplitude. Okay. Let's draw the curve. So, okay, there we go. And that's the curve. Now, again, the period, frequency, amplitude, all of that doesn't change with the horizontal shift, but there is a phase shift. We go from here to here. right? We've shifted from the definition of the sine, where it would start at 0, we've shifted to the left pi over 4. Okay, so now here we have an amplitude change. We have a scaling of up by a factor of 2 about the y-axis, and then there's been the curve is shifted to the in the positive direction, pi over 3. So okay, we've got this is going to go from 2 to -2, and then there's been no scaling about the x-axis, so the period is still 2 pi. So let's see. Okay, so now let's see. Pi over 3. So okay, there's 5, 1, 2, 3, 4, 5. There's 5 tick marks. What is pi over 2 divided by 5 is pi over 10. So each tick mark then, now how many tick marks is pi over 3? So we want to do pi over 3 divided by pi over 10. 3 1/3 tick marks. So 1, 2, 3 around here would be the new start point, but then that's off the graph to get to the end of the period. So we're going to have the start point be over here. So 1, 2, 3, 3 1/3. Okay, but this is a cosine curve, so it's going to, at the start point, it's at the positive amplitude, so here. And then it's going to end at the positive amplitude, so here. Now at the midpoint, 1, 2, 3, it's going to be at the negative amplitude. And at the quarter point, it's going to go through the x-axis. Okay. All right, so now let's copy this down the graph. And there we go. So the phase shift, we've got the cosine graph being shifted pi over 3 to the right. This, you can think about this cosine graph that has an amplitude of 2 and a period 2 pi has been shifted to the right pi over 3. Okay, here, so now we've got a scaling mixed in with a horizontal shift, scaling about the x-axis, and this is already, in a form, the kind of the best form where you can interpret the transformation. So this is what we talked about this in the previous video, but then also in the video with the link in the description. And so you've got it factored to where you factor out the 2 here to where you have a coefficient of 1 in front of the x. And so you can look at this is that this is a shift of pi over 4 in the negative direction. Then it's a scaling of about the x-axis of 1/2, and then a scaling about the y-axis of 3/2. So, okay, we're going to go from, let's see, I'm going to put these major tick marks as always as integers. So I'll do 2 to -2. And so then let's see, 1, 2, 3, 4, 5. That's 1, 1, 2, 2.5. That's the positive amplitude, and then 1, 2, 2.5. That's the negative amplitude. Okay. Then the period is scaled down by a factor of 2. So 2 pi divided by 2 is pi. So let's go from minus pi to pi. 1, 2, 3, 4, 5. Okay, so now we've shifted to the right pi over 4, so we'll do the new period is we're going from here to here, and so the sine curve starts at the origin and it ends at the origin, and then at the midpoint it goes through the, or not the x-axis, starts the x-axis into the x-axis, midpoint goes through the x-axis, and then the quarter point, there's been no flipping here, goes through the positive amplitude, and the 3/4 point goes through the negative amplitude. Okay, so let's see, we've got, and there we go. So now let's, and there we go. So what we've got here is the phase shift is pi over 4, but we've shifted the sine curve with amplitude 3/2 and period pi. The period has been shrunk by 2. We've shifted. So typically, if you shift sine of, like, just sine of with period 2 pi to the left pi over 2, you get cosine. Well, since the period has been shrunk by 2, then all we need to shift this curve is pi over 4 to the left to get to the cosine. So if we graphed 3/2 cosine of 2x, that's what this is. But technically, though, this is the, you can see it's the sine curve with amplitude 3/2 would start here, but it's been shifted this amount of phase shift, pi over 4 to the left. Okay, so here we want to rearrange this x area here to put it into a form where we can more clearly see the transformations. So what we'll do is minus 4 sine of, we want to get a coefficient of 1 or minus 1, but here there's no minus, isn't a factor, in front of the x. So 2 and then x minus pi over 2. Okay, so now we can see this has been shifted to the left pi over 2, scaled down about the x-axis by a factor of 2, scaled up about the y-axis by a factor of 4, and also flipped about the x-axis. Okay, so the period is going to be pi, because it's been scaled down by a factor of 2 from 2 pi to pi. We'll do, let's see, so we've got 4 minus 4, and then the period will go minus pi, pi, okay, so let's see. Now we've shifted to the right pi over 2, but we'll make this the end of the period, so we're going to sketch from minus 3 pi over 4 to pi over 2. Okay. Now we've got the sine curve, so that's going to start at the x-axis and end at the x-axis. At the midpoint, it's going to be at the x-axis. Okay, now at the quarter point, it's usually the positive amplitude, but this has been flipped. So we go the negative amplitude, and at 3/4 point, the positive amplitude. And there we go. So let's, Or wait, where am I? No, okay, here. Yeah, here. Okay, we're here. This is the 3/4 point. This is the end point. Okay. So okay, and there we go. Let's copy this. I don't think I drew that peak exactly right, but you get the idea. No, it looks good. It's good. Okay. And there we go. Oh, yeah, the phase shift is, so it's originally a sine curve and it was shifted to the right. So this is the phase shift. Right? It's the sine curve, but it's flipped about the x-axis, so it's shifted out here. It starts negative. Okay, let's rearrange this and get it into a clear form to see the transformations. So let's get a coefficient of 1 in front of the x. Let's see. This is going to be pi over 2. Yeah. Okay. So this has been shifted to the left pi over 2. It's been scaled up about the x-axis by 2. So the period's going to go from 2 pi to 4 pi. And then the amplitude has been scaled down by 1/2. So again, I want to put integers as the major tick marks here. So I'm going to put 1 and then 2, 3, 4, 5. This will be the 1/2 point. 1, 2, 3, 4, 5. There's the negative 1/2 and then negative 1. And then we'll go from minus 4 pi to 4 pi. So 1, 2, 3, 4, 5, negative 3 pi, 1, 2, 3, 4, 5, negative 2 pi, 1, 2, 3, 4, 5, negative pi, 1, 2, 3, 4, 5, pi, 1, 2, 3, 4, 5, 2 pi, 1, 2, 3, 4, 5, 3 pi. Okay, now we've shifted to the right pi over 2. So 2.5, like right in the middle here is pi over 2. So this will be the end point, and then we'll start here. So we'll start here. Okay, so there's our new sketching interval. We've already accounted for the, yeah, we've got everything accounted for, the scaling about the x and y. So now let's just put the points. So at the start of the interval with cosine, it hasn't been flipped or anything. It's at the positive amplitude. So here. And at the end, it's at the positive. It comes back to the positive amplitude, so here. At the midpoint, it's at the negative amplitude. So 1, 2, there we go. At the quarter points, it goes through the x-axis. Okay. Oh, wait. No. So 1, 2. Yeah. Okay. So we've got like that. And then And there we go. Now the phase shift, it's cosine shifted to the right pi over 2, so there's the phase shift. Okay, so let's start by, let's rearrange this x portion here to get it in a form where we can easily see the transformations that have been applied. So we've got minus 4 sine, and let's factor out a 2. So we want to get the x to have with a coefficient of 1 or minus 1, but there's a negative, a minus 1 is not a factor here. So we have just x by itself minus pi over 2. All right, so now we can see that this has been shifted to the right pi over 2, and then it's been scaled down by a factor of 2 about the x-axis. And also it's been scaled up about the y-axis by a factor of 4 and flipped about the x-axis. Okay, so we've got, let's see, we're going to go from 4 to minus 4. The period has gone from 2 pi, then it's been divided by 2, so the period is pi, so we'll go okay. Okay, so we're going to shift to the right pi over 2. So we're going to shift all the way to here. And so we'll draw the curve going from, let's see, going from pi over 2 to, that's a period of pi. Okay, so the start point is at minus pi over 2. With a sine curve, we start at 0 at the x-axis, and same at the end of the period. And in the middle, we're at the x-axis as well. So, but at the quarter point, we're usually at the positive amplitude, but since this has been flipped, we're at the negative amplitude. At the 3/4 point, we're at the positive amplitude. So, okay. There we go. So now let's copy this. And there is the graph. And okay, it's been shifted. We had the sine curve that's been shifted to the right pi over 2. There's the phase shift. This sine curve with, it's like sine of 2x or minus 4 sine 2x, right? Amplitude of 4 flipped about the x-axis. Period shrunk by 2. Minus 4 sine 2x has been shifted to the right pi over 2.